Good afternoon. This is Panda Consulting's ArcGIS workshop. I'm Frank Conkling, and this time we're going to do something a little bit different. Rather than doing a demonstration or a workshop or looking at some of the more technical component, I recently had somebody ask me about, well, how did you used to do it in the olden times? So I started reflecting on the fact that I've actually been mapping parcels for over 50 years. And I started thinking, well, why did we do it a certain way and how did we do it and what did that change about how we're doing things and what we pay attention to now versus what we used to pay attention to. So that's what we're going to do this time. We're going to talk about that more than anything else. Before we start, I just want to go and remind everybody the QR code in the lower right corner will take you to Panic Consulting's website where you can see who we are, what we do, why we do it, how we do it, and such. We are also, in fact, an ESRI business partner, have been for since we came into existence. We are the first business partner to go and receive the parcel management specialty, recognizing our expertise in parcel management and the ArcGIS parcel fabric. We also have a release ready specialty and a state and local specialty. So let's get started. Um, Simple statement. Parcels are complex. Uh, when we first started talking about parcels, when one gets involved with parcels for the first time, they think it's fairly simple. And I recently had some experience with a client in which they thought, well, parcels are parcels. It's simple things, right? And I started explaining to them how parcels, for the most part, are a recognition of the way in which we in the United States own and hold and possess land, that right to use land. And that the more you understand about this, the more you understand the complexity of it. And in the past, our technology was such that it kind of minimized what we could actually do with it. But now we're actually starting to get some technology in place that allow us to explore some of this complexity, explore some of this richness of what a parcel really is. And we're going to talk about that a little bit more. But let's start with this. That parcels really, once you understand them, parcels are complex. They're not simple by any means. But again, the technology that we use to handle these parcels dictates the level of complexity because the more our technology improves, the more our technology moves us along in sort of this spectrum from simple cave drawings until where we are now, it allows us to go and get this full richness of that complexity so we can begin to understand a little bit more and more about it on here. Um, and just with this statement, as far as we progress with the data models that we use for parcels, we're not done. There is still room for improvement on here. And at the end, I'm going to talk about what I think we should be improving and what we should be looking about or thinking about. Again, just a reminder, I'm not just a GIS parcel mapper, but I'm also a land surveyor. So I sort of take those two different lives and pull them together and I come from both of those. I'm the platypus, if nothing else. So the first thing is, and when I tell people this, it sort of is my first parcel map that I ever drew was I was drawing parcels, but it wasn't on Mylar, it was on linen, and I was using ink. I was using a pen to draw it on ink. And this was a parcel map of a town here in South Florida called the town of Lake Park. And the company I was working for said, we need you to show us where these parcels are and how they relate to one another and where the roads are and such. So my first parcel map consisted of me drawing parcels on ink on a sheet of linen. And that leads us to the realization that I guess I've been working with parcel fabrics my whole career, even though I didn't realize it, that what I was starting with was a fabric in which had parcels. And I'm still doing that now, and I'm enjoying it. And hopefully I can bring some insights into the rest of you. So let's start with, okay, different technologies allow different concerns, and the data models we use define how deeply we can think about the parcels. And here's the different models we're going to look at. We're going to look at hand-drawn maps. Well, some of us who have been around enough recognize these are the maps that we would draw, and we would draw them on Mylar or vellum or linen in my case, whatever we started with. And that's how most of us started mapping. And then we started maybe a transition from there in the early to mid 80s. CAD came into play and we started using CAD files. Then we started looking at GIS and how to do it in GIS. We started progressing through there into intermediate GIS formats. Then we went to the ArcMap parcel fabric. Then eventually we went to the ArcGIS parcel fabric. We're going to talk about each of those different formats and the benefits of each and the limitations of each. And then we're going to talk about hopefully the future. So this is where I started. And this, believe it or not, my first calculator, the first thing I actually had to do was I had to learn how to use a calculator. And right here, right here, this is a Monroe calculator. This was not electric. This was hand and it was mechanical. This was the first thing that my employer said, you've got to learn how to use this because this is how you're going to do all your calculations. But we have to go and calculate how to draw and how to lay things out. And then right next to that was, this is a logarithmic table. This is how we would derive the sines and cosines that we would use to go and lay out our actual drawings. Of course, we also had drafting tables. That was essential. This was the technology that we used when we started doing some of these hand-drawn maps. Things like triangles and compasses and all this equipment, so that even though it was a simpler time, there was a lot more technology that we were using. It just wasn't computer technology. It was simple technology. And believe it or not, this here in the lower left, this was by far the most important thing that we had, a scale, an engineering scale. And it would help us go and put together and figure out where things were because we were not working on a flexible format, flexible data model. It was fixed in scale and we had to make things scale up, scale down to fit in there. So let's look at some of the things that we've got here. So let's start with this. The first data model that we had, the first way that we would conceptualize where our parcels were, is basically a cartographic data model. It was putting together a map that was a message of what was important about those parcels. All right. And it would include things such as what's the overall location of that parcel, what's sort of a general geometry for that parcel, how does it relate to other things around there? And the thing that's very critical, and one thing I want to make sure we understand is that that cartographic data model is implicit in nature, in that in order to go and understand what that message was about how big something was, how it related, you had to read the map. You had to figure out what it was because, and the way you did that is you looked at it and you interpreted the information that was put on that map so that you would have things like pieces of text on the map and arrows pointing to these things, trying to tell you that's what that thing is, or that's what that line is, or that's what that parcel is. None of it was built in. It was all implicit. You had to go and read it. You had to figure out what is this thing I'm looking at? And that gets complicated into things like, as we're talking about now, multi-purpose cadasters, in which we have not just parcels, but we have partitioning of data, things like the public land survey systems, subdivisions, lots inside those subdivisions, road rights of ways, rivers and things. We had to go and put those things that were important onto that map, and we had to go and make sure someone understood what they were. And we do that all cartographically. All right. The other thing about this was that these parcels and these maps were not contained in this overall company-wide or county-wide sheet of data, but rather it was freestanding sheet in that we were limited by the media in which we were using, so that you'd have to get and put together an individual inset almost to say this is the area that we're looking at. And if you were doing any sort of mapping in a larger area like a county, you literally had sections or sheets that you would put together. And those of us that were doing it long enough understood that there were issues in that when those sheets were usually square or rectangular in size. And when you tried to put things next to one another, they wouldn't match. Those streets wouldn't connect up to one another. There were issues with them because it would not go and handle that connectivity very well. And what that meant was that these original hand-drawn maps were difficult to integrate with any other thing. When you went to go and share a map with someone else, the odds are that if they were going to go and integrate it into what they were doing, they had to go and scale it up, scale it down. And we became wizards with the Xerox machine being able to go and scale things up a percentage, down a percentage to make it fit. But again, the biggest element we want to bring out of this is that when we were drawing these maps, our primary concern was making sure that all the features that were important were being shown, all right? And that we didn't leave parcels off. We weren't as concerned about is this drawn as accurately as possible because there was no way of knowing specifically. There were no real coordinate systems in place. There was nothing we could snap to. It was all hand drawn on there. And surprisingly, I've still got some clients throughout the country that even now they're still doing hand drawn maps because they're comfortable with them. The public is comfortable with them. But again, you wanted to recognize that one of the limitations of this is that there was no way to verify. It came down to basically cartographic license. How well did it look? And that was often how they went and interpreted whether or not it was accurate, was whether or not it looked good on there. Well, then back in the early 80s, we had CAD, especially uh, PC-based, personal computer-based CAD systems came into play. Interesting, before CAD came into play, I was actually working on some timeshare computer systems in which I would calculate coordinates by using some very, very primitive coordinate geometry packages. These COGO packages were very interesting to work with, and you would assign points and you would go from point to point to point, and you could get a readout of what those coordinates were and maybe transfer them over. But the important thing about these CAD packages were, again, it was still a cartographic data model. You interpreted you interpreted the what was put on the drawing and used that to figure out what something was supposed to be. They were limited in scope in that they couldn't be used for large mapping systems. You couldn't use them for a county-wide system. You would not be able to go and have all the county parcels in a single file. You basically had to break it up and split it up into these other files. Um, one of the one of the characteristics of these early CAD systems was that when you had a drawing, because of the linear nature of that DWG or that CAD file, is that if you had a drawing, some of the things that start drawing, and it would start drawing from the upper right corner, and it would draw these things out here, and eventually get down until it finally drew in the lower corner. It was very characteristics, and you would sometimes wait to watch it draw and draw and draw and draw and draw. Matter of fact, some of the early GIS systems worked the same way. But this was sort of the characteristics of some of those systems. It was not optimized at all for large databases. And many times, many times in that it actually had just minimum implementation of projections. And this is characteristics of sort of the surveying profession at that time. Surveyors they have to work on ground distances, and often at that time we were still using ground directions. But as we started moving further, we started integrating projections more and more, and you're start you're starting to find that CAD files are starting to understand and apply projections to them. But for the most part, it was still sort of, okay, what am I doing here? How can I do it? It's a small project. I don't need to apply a projection because there's not that much difference between ground coordinates and projected coordinates on there. So with CAD files, you were still limited in the quality of the data that you were actually using and what you were putting in place there. With CAD files also, though, came the introduction of COGO. Again, the widespread use of COGO. Coordinate geometry was actually very interesting. And I remember going around in the mid 80s saying that if you want to have, if you want to have really high quality and accurate data, you needed to begin to use COGO because it was structurally, geometrically, it was a much sounder way of mapping your parcels. It was not relative to anything else around there, but it would, at least that parcel would be geometrically sound on there. Didn't mean that the parcels were accurate. It just meant that geometrically they were much better than where they were previously. And what I mean by that is that it would very clearly go and show you what that was, but you could still place this in the wrong place. You know, it did not do anything to help you identify how to place something, but at least it would build a strong geometry from there. Also with CAD files, we started seeing more and more the use of traverse closures. A closure is really when you go and utilize information included on the legal description, especially the meets about description, to be able to determine whether or not your parcel mathematically closed upon itself. One of the misbeliefs, though, is that a good traverse closure is an accurate parcel, and that's not correct. Again, you still have that issue is it in the right place? And then secondly, what you have to recognize is that traverses and closures on traverses are really not a measurement of accuracy, but they're a measurement of precision. How well is that measured? How well is that line measured? How well is the angles measured on there? Because if you take those same angles and reduce the precision of them, you will get a different reading on your traverse closure. Then if you go and extend them out to more decimal places, you'll get a much higher closure ranking. So traverse closures does not mean it's accurate. It just means that it's precise. Right? Again, with a CAD file, because we didn't have any way of thinking about where these things are supposed to be, and we really had no way to go and tell, are they overlapping? Are there gaps between them? We really couldn't be concerned much with whether or not they fit together, or what we in GIS call topologic integrity. All right. So CAD files was a better way of making drawings than hand drawing them. It was faster. We could do it better. We could replicate it. We could actually share it, but it didn't mean it was a better parcel data model. It just meant that it was taking the old way of doing things and finding a way to make it faster. That's all it was. I still get into discussions with surveyors, and they're saying, well, CAD files are more accurate than GIS, and it's not that they're more accurate. They have a different scope, they have different definitions of accuracy, but that doesn't mean that they are more accurate than GIS files are. Uh, by the way, thank you all for being here. If you got any comments or questions, put them over in the chat window. Chris is here, he's moderating it, and he'll be make sure to cut in and make sure I stop talking to at least address some of those concerns. All right, so then we get into the initial GIS. And yes, by the way, this is a picture of Jack Dangerman in 1987 in one of the early interviews he was doing. So once you introduce GIS in here, you started changing sort of how things were represented. This data model changed. So it started introducing the concept of a feature-based data model, meaning when you looked at something, when you touched on something, a polygon could have attributes about it that said, this is what this is. So you didn't have to have pieces of text to say, that's what it is. Interestingly, though, we still were producing maps. So we still had to go and put pieces of text on our map to go for those people that were using that paper to figure out what that is. If we were using the actual GIS system, we could click on it and say, that's what it is. That's the properties of that on here. But GIS, some of this initial GIS started introducing this concept of a feature-based data model on here. And some of these early data models were, shall we say, a little rough. Things like ticks and edges and the arc node topology. Some of those things, they helped us understand how to do this a little bit more. And we started thinking about, well, how do we start integrating not just one set of data, but how do we start integrating multiple sets of data, which, by the way, is a definition of GIS, as you start looking at the different types of data and how it interacts with one another. And some of those early ways of doing this was we would often build things like coverages with regions, and the region would allow us to go and build the geometry for this, and then use that geometry to build something like this, and then that geometry to build something like this, and we could pull them out and we could analyze between them. There was also an integration of spatial projections so that if you had it on a known projection, you could go and analyze between them. The introduction of topology, again, that arc node topology really helped us to understand, again, some of the complexity of parcels and how things interact with one another, being able to go and identify whether or not we'd have a gap or an overlap between certain things. This spatial overlay analysis, which is a key to GIS, was just introduced back in the mid 80s on here. And these were really concerns of what we do. By the way, those of us that were working and using ArcInfo, this was a Sun Spark station. One of the things I worked on Sun Spark stations. I also worked on Data General, Unix boxes. And so we also had to learn a whole nother operating system on there. But what happened was, rather than making sure that everything was shown, this new way of data modeling said the primary concern was ensuring that all features are shown, but then also considering, are they contiguous one another? Are there overlaps or gaps and such? We also started better representing what the area was that was concerned. Still using things like COGO, it didn't necessarily mean that it was more accurate. It just meant further along on that continuum as we were going. And again, I would include ArcInfo workstation and ArcView 3, sort of in that same initial GIS groups. The differences were that ArcInfo workstation used some of these earlier data structures, such as coverages and regions and such, whereas ArcView used instead a new structure called shapefiles, which is a way to go and put this onto a different system using older DBase extractions to go and figure out where one file contained the attributes and another file contained the shape of that. Another file contained a spatial index. And that spatial index, that was huge when it was introduced with ArcView. And that instead of waiting for that drawing to go and start here and come all the way down here, the spatial index went and analyzed your drawing, all the features that you have drawn in here, and it said, okay, let's go and look and let's analyze where these features are and actually have a separate index to say that these features are located in this grid on here. And it would actually go and put a grid over all your data. All right, and figure out where it was so that when you went to go and draw on a certain area, the first thing it did was said, just pull back those features, those lines, those points, those polygons that are inside the area that I'm drawing on. Don't pay attention to the things outside the area. And that was for drawing. That was for going and locating and finding. That was a huge increase in the ability to go and use large county-wide and statewide data sets, was this spatial indexing component built into ArcView on there. It was a huge step forward and helped us a lot in what we were doing from that point forward. Parcel, so we were still very primitive in there because while we could have lines and polygons, we weren't quite at that point where we could get them to represent one another very well. All right. So we had still this new format, and this is ArcMap. ArcMap, almost 25 years old now, was still primarily a cartographic data model. It represented things with lines and polygons and points, but it did not relate them very well. You still had to go and represent them on a map for there to be much quality on here. And this is the interesting thing about this is that all too often the focus was still on producing a map. It was producing a map. And, it was still primarily a cartographic data model. That cartographic data model, again, you had to put on that map those things that you wanted somebody to pull out of there, things that you wanted to go and do the analysis on. All right. They were beginning to go and do things like create some connections, some relationships between the features themselves and what it was represented. So you would get things like feature linked annotation in there. You would get a deeper integration of topology, but overall there was still this heavy dependency upon annotation. Now I can tell you that working with multiple clients across the country, we still have this legacy of this cartographic data model, heavy use of annotation on here, where you have pieces of text placed on your map. And the reality is that you should have a feature. If you want to put something about a feature about a line, what it represents, you should embed that information into that line so that it can be used for analysis, it can be used for representation on there and such, not annotation. Annotation still goes back to producing a map on there. Again, we still see this all the time, and a lot of our work in the migration from these old data models into a more complex parcel data model involves how do we capture that annotation? How do we go and associate that with the individual features that are actually representing it and such? Prime example of this is if we have, for example, a lot. Again, a lot is a partitioning of a subdivision and how the lots are in here. Often what we'll have is we'll have lines and polygons representing the parcel boundaries, but then separate lines representing where the original lots may have been built. And while that's fine for producing a map, in order to be able to go and calculate things such as how much of this lot is involved in this parcel, you need the actual feature representing what the boundaries of that parcel are. So it's this migration into a feature-based data model that's actually most important for us to be able to go in the future, determine what things are, how it's represented and such. Which brings us to the ArcMap parcel fabric. And this was the first initial attempt to really integrate these cadastral concepts into a data model. And it was a really interesting data model as far as what was being built in here. So that let's start with this analysis. And let's say that a parcel is actually built up of the polygon that's included in there, the lines that serve as a definition of that, and anything else that's related to how that parcel is defined. So, for example, perhaps it came and started at an individual control point or a known monument that's called out. And then there's courses that are called out in the legal description or the survey that says this is how you get to the control point or the big point of beginning of that parcel. And then there's further courses and further calls to the actual boundaries of that property. All right. This was the first data model that really started integrating them and pulling them together and saying, this is the definition of a parcel, not a polygon that has some lines on it. Because previously you had no way of relating those lines back to the parcel that was part of their definition. So you would have a line that was used and it might be able to hold information about one side of that line, but not the other side of the line. So this ArcMap parcel fabric was a really good start because it integrated into it this relationship between the lines, the polygons, and the points. Now, interestingly, from a actual legal definition of a parcel, these points represent corner monuments on here. In the United States, a parcel is not defined by the lines. It's defined by the corners where those monuments are placed, those corner monuments on here. And that's what defines where a parcel is. And we're eventually getting around to understanding that and integrating that more and more into our system. So the different thing was that this actually used explicit joins, recognizing that in fact, this parcel, I'll clear that out, that this parcel was related to this point at some time. And how was it related? There was then this explicit join that said that this line connects to that point. This line connects to that point. This polygon connects to these lines in here. So the data model in the ArcMap parcel fabric created these explicit joins. And it was a good data model, but it did scale very well. And that those of us that actually use this data model, once it scaled up, it became cumbersome to work with. It became very, very difficult to work with. Things like you would have line points, points on lines. So that you might have a longer line here, and that point is supposed to be on that line. So it would create these line points in there, and maintaining those line points became very, very cumbersome, difficult to do. And that was one of the things that Esri looked at when they started building up their new parcel data model. It uses points as the primary locator. Interestingly, though, the ArcMap parcel fabric used lines as part of that relationship class, and that they would have a what they call a plan table that said, okay, let's relate the lines, and those lines are going to define what points they start at, what points they end at, and then what parcels are defined by those lines. So it built this relationship that was compliant with sort of legal principles, but it still had some issues with it. And again, it didn't scale very well. So that when you started looking at large implementations, it was problematic. Um, there's also something that it introduced that is very, very interesting. It's one that especially is important when you deal with parcels. And this is a concept called inference. Inference means that this line is not necessarily defined by just a bearing or just a direction and a distance, but that line is defined by what calls are made to monuments in here. It introduced the concept of monuments in that there can be natural monuments, the river, there can be physical monuments, a tree, a stone wall. There can be what's called record monuments being this is the right of way of this property, or this is the right of way of a street. This is a section line. These are not physical, these are abstract, but they are known as far as where they are. And that those monument calls, all right, so that if in fact I had an easement, for example, that I was doing, that easement would be called out as being a certain distance away from another line. This certain distance here, this is called inference. So that when I infer that this should be 12 foot or whatever it should be in here, that means that when this line, that monument call line, when that moves, when this thing moves, it should also move this. And with the ArcMap parcel fabric, there was a limited inference because of these joins and the way they worked. There was the beginning of this inference. Not there yet. It was the beginning of us being able to see how this might work. Because when I moved a point, it would move everything that's connected to that point, not just what's directly connected to it, which is what topology does. So it was the beginning there, and great ideas, but because of the limited ability for it to scale up, it didn't work as well as it could have been. So what happened is we've now come with a new data model. This is the ArcGIS Pro data model. This is the current best practice. And there's a relationship built between what is a document reference, or using survey speak, a record call, all right, saying everything is related to this record and all the information that you need to understand where this is, it's all on this record. And for the most part, that's a document, a deed of conveyance or a subdivision plat, or up in Wisconsin, a certified survey map, or in one of the PLSS areas, this is the public land survey system plat on here. It would all be related to that record call. And then the parcels are defined as being related to coming out of this record. The lines are the same way. The points are the same way. They all are related to that record. And this is a good way of beginning to build up this relationship class on there. However, because of the problems that we had with topology, with the joins inside of the ArcMap parcel fabric, Esri has decided to go and use topology instead. And if you understand how topology works, that's great. You can now have that flexibility to be able to figure out when I move something, does everything move or does it not move? Matter of fact, with some of these newer versions like 3.6, 3.5, and 3.6, Esri is built in there where if I go and move a point that's associated with a line, it won't necessarily just move it so that that one point moves, but it might actually move my entire line the same way that I moved my point. So it's beginning to understand a little bit more of this inference on here. It doesn't work all the way yet, but it's a much better way of looking at how things interact with one another and what is related to something else in there. Also, inside there, we also have these monument calls that are stored on the line feature classes. All right, so that now we can take Kogo, and Kogo was not meant to be used for labeling like it was in those ArcMap um, data models. It's not for cartographic purposes, it's for analysis because now all our Kogo calls are real numeric values, and you can begin doing analysis and saying, okay, where is it that our distance that's stored in the Kogo distance field, where is it differing from the actual shape length of the line? Where is it above? Where is it below? Where is it outside of a certain variance in here? It allows us to start doing some analysis on here. It also allows us to go and start looking at where did this Kogo come from? Where did this coordinate geometry values that we use to build this geometry? Where was that coming from? Was that coming from the actual mapper that they went and inputted there? Or was it just calculated from the actual shape, the geometry shape of it? Where was that built in there? How did it come from? And you can use that to analyze. It's a very subjective way of looking at this. And finally, well, not finally, but it also includes the ability to start looking at lineage. What happened to this parcel? Where did it come from? What impacted it? Why did it impact? Who impacted it? All of that is built into the new data model on here. History is built into this data model. And you can track what record here actually caused there to be a change in my data. And from that, with this relationship class that we're building up now, we can actually start building things like actual lineage diagrams that show us where these things came from and what caused them to be a certain element in here. And we can begin to see this complexity building out without us doing much extra work. And finally, with this new ArcGIS Pro parcel fabric data model, we now have the ability to include strata parcels. And these are very, very simple 3D parcels, meaning vertical extrusions that can occur, both visual and true extrusions we can do on there. It's not a complex 3D. So, for example, if I have a two-story condo and it overlaps on top of one another, it can't do that yet, but it can do extrusions and say that this unit is this tall, and here's the overall planar shell shape of that when you're going through. So it's, again, movement along that spectrum to get us back to where we want. It's moving along, it's getting better and better, and it's starting to understand more of the complexity because parcels themselves are not simple. Parcels are not just land parcels. They are a way of keeping track of some sort of usage of the land. We can do things like map space now. So we can look at air rights. We can look at subterranean rights. We can look at condominiums. Condominiums are 3D. They are not describing the land, they are describing the space on there. And we're seeing that inside of here. So again, this technology is improving more and more as we're going through these different data models, and it's allowing us to really start expanding and understanding a little bit more about our parcels, what they are. And then finally, what we have is where do we go from here? And we're seeing a lot of work being done now on complex models where we can have not just little square boxes, but we can have multiple floor models in here. And so that we can really go and model the actual shape of a condo unit if it's 2 stories, 3 stories, and it has different floor plans for each of them. How do we do that? That's coming. That's coming. It's going to be really, really useful. It's going to be a different data model than what we have right now. Also, we're starting to understand how to go and utilize temporal models. Temporal models have to do with time. And it's something as simple as how do you model the interest that someone has in this parcel? When does it start? When does it end on here? And most people don't realize this, but things like easements, an easement is not a perpetual easement. There's a limitation on it on a legal standpoint. That in limitation might be hundreds of years, but there is a limitation on it on when it's created and when it goes and expires. Also, there's other types of temporal models. For example, a timeshare where I might buy 2 weeks worth of use of a space on here. We still don't have a way to model that at all on here inside of our parcels. We're going to have to get that soon because that's going to become more and more important as we're looking at finding ways to go and do that. And this is one that really, really concerns me is we've got to find a better way to capture monument calls. So, for example, if I go and have a legal description that has a bearing and a distance along the line, but it also tells me that that is actually the west right of way of a line, I have to find a way to store that there so that I can use that to go and analyze what defines that parcel so that maybe if my right of way moves, that line can move also as a result of that. Or that I can use that for possibly some labeling options to go and make it better message to the viewers or users of that data what that line actually is defined as. Right now, it's just a line. There's got to be a way to capture some of these monument calls in here to make this more meaningful, to make it so that we can capture something more than just this is a line. Oh, this has a direction or a bearing on it. Oh, this has a distance on it. The same way with our points. Points are supposed to represent the corners of the property. Again, in the US, this becomes really, really important. And I suspect it might be sometime within the next 20 years, we're going to start capturing what these corners are and using them. Right now, for the most part, we're disregarding them, but they become critically important as we move through. And I know that certain other areas, such as up in Canada and other areas, those calls are very important. And they've actually able to use coordinates to define some of the locations of these corners. In the US, we are still not able to use coordinates to define locations of a corner. Not actually legally to be able to go and use that as a legal definition of it. And then finally, what I think is going to happen is I think we're going to start seeing more and more an understanding that parcels are not just simple geometry, but they are related to other things. They are related by inference to these other lines in here so that as we move certain lines, other lines move. Other lines that aren't directly topologically on it, but are rather connected to it or implicitly related to that. Those people who are right now going through remonumentation understand how this works and why it's so difficult because if we have an existing section line in here and we've got a series of tax parcels in here, and these tax parcels are all related to the location of that section line, if we go and redefine the monument located on the south here over to here, and it means that this new section line goes here, well, you know what should happen is that these other lines should automatically move over here. That's inference. That's that, in fact, it should infer that these things are related to one another. It doesn't work yet. It does through some topology. And by the way, that also means that this parcel actually needs to go and change its location relative to that. It needs to be a little bit sticky in here. Sometime in the future, we're going to actually have a data model which helps us to go and do that. So, line on this. What I've seen in 50 years of parcel mapping is we went from drawing ink on linen, where we had to go and say everything that was important about this. We've gone from there into, okay, how do we start building a data model in our GIS that more closely represents how the actual parcel information and the definition of the parcel is on. And we're getting closer. We're not there yet, but we're getting closer on here. All right. Any questions or comments? I don't see any over in the chat window. Does anybody have anything? If not, I'm going to go and say thank you all for attending. Hopefully you enjoyed this. Go ahead and put some comments up in our YouTube, and I'll see you in a couple weeks for our next workshop. Thanks.